So in 1859 in Australia, there was a man and he let loose 24 rabbits into the wild. Well, the rabbits just grew and grew and grew, like the population grew and grew and grew, and after a while they had millions of rabbits, and it was a serious problem for the country, and they needed to, do something about these rabbits eating up all the vegetation and thing. But that is an example of a population growth. Oops. And population growths usually follow an exponential model. We've talked about that in the past. In this section, in 6.6, we're going to show you how to solve exponential equations and logarithmic equations. We're going to start with the exponential equations. And we have a property, it's called the one-to-one property of exponential functions. And it says if you have an exponential function, and it equals another exponential function with the same base. Now that base has to be greater than 0 and the base cannot be 1. But if that's true, then you can say x equals y. And this is an if and only if situation. That if x equals y, then this is true. And if this is true, then x equals y. Now, we're going to use that property to solve an example here in a minute. But let's say you have something like, 5 to the x equals 5 to the third power. Well, then x has to equal 3 because the bases are the same and they're equal to each other. It's already an equation. Now, students get confused on why this is. You're not taking a root of both sides. You're not raising both sides to a power. You're not dividing both sides by 5. People think that. No, you're popping out these exponents and you're saying, okay, if this exponential 5 to the x equals this exponential 5 to the third, then x has to equal 3. So like you're popping out those exponents, okay? All right, I call it the pop out. All right, so now let's look at this example that we have. We have a base of 2 to this exponent, x minus 1, and we have a base of 2 on the other side of the equal sign. So these two expressions are equal, and we have an exponent 2x minus 4. Well, then that exponent has to equal that exponent. So we can just pop out the exponents. X minus 1 equals 2x minus 4. And then we can solve that equation. That's a linear equation. Subtract x from both sides. And we get negative 1 equals x minus 4. And we're running out of room. Add 4 to both sides. And we get 3 equals x. Now you can plug that in to make sure that it's true. 2 to the 3 minus 1, does that equal 2 to the 2 times 3 minus 4? Well, here you get 2 squared, which is 4. Here you get 2 to the 6 minus 4, which is 2 squared, which is 4. So yeah, this checks. You don't have to do the check, but I just wanted to show it. You have to be really careful when you're writing these to make sure you know what is in the exponent. Okay? All right, so that's what we're doing with these.